Hi everyone, this is Aman Soni and I'm the part of GeekyAnts AIT. So in this particular session, we'll get to know about the Retrieval-Augmented Generation, which is commonly known as RAG as well, right? So there are three portions in this particular session. First one will be what actually is RAG. Second one, how do we use that? And third one, what was the need of the entire RAG architecture? We already have our LLMs, we already have our agents. What was the need of using the RAG, right? So let's start with a simple question first. And let me quote you a number. That is 95% of the entire database of the entire world's data is private, and only 5% of the data is publicly available. And the LLMs are trained on that data, right? So if the LLMs are only trained on the 5% of the publicly available data, how are you supposed to get the answers on your own data, right? Let's suppose in your organization, you have to find out how many employees are earning above this much number, right? So how are you planning to get the answers from the LLM on the basis of the context that it isn't aware of, right? So how to use LLM on your own data that is private? This is the major question that comes before the RAG approach. So to deal with that, what happens is there is a flow in the RAG architecture. Let's start with the input query. That input query is nothing but the prompt that you give in a LLM in any kind of large language model. Let's say it is GPT, let's say it is Olama or any other large language model. So there's a process. Initially, you will input a query, right? The user input is processed by the retrieval component. Then after that, there is a retrieval component. So let's say if you have a database in which you have some PDF files, you have some Word files, and you have your SQL database that is attached to that particular document, right? So if you want the answers to be taken from that particular database or from that particular document, it has to be retrieved from that, right? So it has to be retrieved in a way that it doesn't lose its context as well, and the context is then passed to the LLM, which will do the generation part. The LLM will generate the response on the basis of the context that you have given to it, and after that it will output you a response, right? Let's see the basic architecture, basic flow of how the prompt works, how the retrieval works, how the answers are being generated. So let's first start with the questions. In Let's suppose you are asking your prompt that I want a data of my company of this year, right? So you have your entire knowledge base in which you have a lot of data, in which you have a lot of tables, a lot of databases, right? So the question will be asked, and that question will itself decide, okay, so these are the kind of things I need to get as an input from the LLM model, right? So it will find out the context that was related to that particular question. Let's suppose you have written, okay, I need the data of 2025, right? So it will fetch the data from 2025 and take it as an input to the LLM model, right? So it will retrieve the data from that particular knowledge base that you are having. It will give that data to the retrieval engine, retrieval documents, and it will give that data after that to the LLM model. And on the basis of that data, the question you have asked will be answered from that particular LLM, right? So how does that document loading works in the first place? Because this is the main idea behind the RAG. First of all, you ask the questions, and then there are a bunch of documents those are associated, and that will be retrieved, and then those retrieved document, relevant document, will be sent to the LLM, right? So the numerical representation of the search will be in such a way that there are a lot of layers. Each document is a layer, and it will be sent to the it will be first like calculated in a way like the cosine similarity will be, if the document has a cosine similarity that is very low, that means the documents are much related to the question that you are asking. It will retrieve that document, it will fetch that document and give back to the LLM. So there are a bunch of approach for the indexing as well, because you can't just connect your database and get the answers directly out of it, right? You have to first index it so that it can know, okay, so these are the kind of relevant document that I really require, because there will be a bunch of data, there will be a lot of data, right? And you can't expect a LLM to you can't expect a retrieval engine on the basis of cosine similarity only to retrieve all the documents that are required for that particular prompt, right? So there are two approaches to that. First one is a statistical approach, that is also a classical approach, in which you are using a bag of words, which is sparse representation. In that bag of words, let's take an example. If you are having a sentence that says, okay, Ram is a boy, right? So the zeroth index will be Ram, right? Then after that is will be a first index, that will be a second index, and boy will be a third index, right? And if you are fetching the third index, right, it will give you the result that will be the boy. But as we know, we have a lot of data, we can't apply that approach over here because it will be too much, too much of the storage will be required for that. So to deal with this, we have the another approach, which is the machine learned approach, that is the embedding, right? So in embedding, what it does is it will take the semantic meaning, it will take the like context of the each and every sentence, each and every word that you are using, and it will store it in a vector database. In the vector database, what will happen is, uh, any kind of questions that you will ask, it can easily find the like similarity between them, because we have the vectors instead of the bag of words, right? We have the vectors and you can easily find the similarity between two vectors, right? So the embedding will be done in such a way, and the representation of this is also called the dense representation. So the embedding is done and the retrieval will be taken care of. Then this is the entire flow of the entire RAG architecture. There'll be a lot of algorithms that will be coming in our future, and there are a lot of algorithms that has already come into the picture, right? So but the entire you can say the flow will be the same, because initially you are going to ask the question, then after that in the routing it will select, okay, so this is the database that is required to answer my particular question. So it will route the question to that particular database, and on the basis of index, on the basis of indexing between the question and the basis of indexing between the documents that you have passed, so it will fetch the relevant documents that are necessary for you, and then after that it will give those documents only to the LLM model. And on the basis of that model and the question that you have asked, the two of the these things collaborate with each other, and it will give you the answer on the basis of that particular document instead of a generic answer that an LLM would have given to you, right? So this is the entire flow of the RAG architecture. And what are the benefits of RAG? Like you can use your LLM model as well. Since we have already covered a lot of things about RAG, you might have already guessed what are the benefits of the RAG. So first one is the enhanced relevance, because there will be a lot of data that is relevant to you, and there will be a lot of data that is not relevant to you at all, and you do not need that as an output from your LLM model, and you need only that the kind of data that is relevant to you. So that will enhance the relevance. And after that, improved accuracy, of course, that thing goes without saying. Then after that comes the scalability, and after that comes the versatility. Then what are the challenges faced by the RAG? First one is the latency, of course. uh, there are two scenarios. In first scenario, you are just asking giving a prompt to LLM, and it is giving you the answers, right? And in the another scenario, you are giving a prompt, and first all the relevant documents are being extracted, and with your prompt, the documents are also sent to the LLM model, right? So of course, the second scenario is going to take a lot of time. Second scenario will be there will be a lot of latency, and after that there will be a knowledge based maintenance, because you can't just attach a database. You have to index it. You have to first pass it and then index it in a way that your questions can be answered in a much relevant way. And there is a model alignment, because there might be a issue where you have selected one model, one LLM model, and then after that, after some time, that LLM model got depreciated and some another LLM model comes, but that LLM models doesn't offer you that kind of accuracy, that much minimization of loss function. So that is an issue here. Then after there is a scalability issue, because we have already discussed, we have to send the entire data to the LLM. So there will be a lot of scalability issue, because there might be a scenario where a lot of data will there will be a lot of irrelevant data as well that can go into the LLM, right? So that is a scalability issue again for us. Then what are the application for the RAG? We have seen what are the disadvantages, the challenges of the RAG, but with a lot of algorithms, with a lot of research nowadays, these are the sort of things that are truly minimizing each day by day, right? So what are the applications that are built on the top of RAG? So first one will start with the customer support. Let's suppose we have a uh, chatbot that answers your question. We have in first scenario we have a normal chatbot which doesn't have a lot of context to it. It doesn't know how to answer that. It doesn't know what are the things he shouldn't disclose. And another scenario where the RAG is attached, it also knows the policy of your company. It also knows what other thing it can give you as an output, right? So that is the customer support, and you can also attach like voice model to it so that it can talk to you over the phone, and you won't even notice is there a guy who is talking to you or it is a ML model, right? And there is a education purpose. Of course, that goes without saying, because in the education you actually need a let's suppose there's a scenario where you have two books and you want to find the answers in that particular book. So you will index that book instead of reading that book entirely, right? And you will just answer the you will just get you will just write the prompt, okay, I need the answers to that particular question, and it will give you the answers after fetching that question. Then there is healthcare, that there is the legal research, then there is the expertise solution, where the internal document retrieval combined with the generative insights. Then what is the future of RAG? RAG gives you a customization over the context, over the answers that you want, that you expect from LLM. LLM as a whole is a generic model, and if you want to do the customization, the RAG has a very bright future for that. So improved retrieval techniques, the integration with the multimodal systems. Multimodal means there are a lot of models that will do the video generation, that will do the image generation, that is going to help you with the voice. So these are the kind of things that will integrate with the RAG to make it more effective. Right. Then there is the end-to-end optimization and the domain-specific RAGs. We have just discussed those. There are a bunch of domains that are available that you can work on, and there might be some more of the domains that we couldn't gather over here. So the domain-specific RAG, tailored solution for the niche industries and the tasks. Okay, so this was the entire learning of the RAG. This was the entire concept of the RAG, like what RAG actually is, how does it operate, and why do we even need one, right? So I think everything was answered in that particular video. Let's code.